Hello, hello. Good time of day, everyone. Let me move this up a little bit. There we go. So, today I'm probably doing a little more experimentation than actually game engine design or anything like that, though I am still using a fork of what we've used before, and we'll probably fold some of it in, or at least make a module that I could use later. So, without further ado, so yeah, fake 3D. So what I mean by this is that proper 3D, generally uses Open GL to use to use well understood systems that actually do proper 3D and ideas, and yeah, I'm not using that. So instead, let me open up a new one. The basics I want to accomplish would be to the level of view down hallway in good old-fashioned dungeon crawlers. Here is your line. Here is that. And then you have a bit of perspective that's baked in, and not like this. So how to figure this out is to do what Doom and various other Super Nintendo games did. One second. Whoops. Alright, that's still working. Is to do what various Super Nintendo games and to an extent Doom did, which is we take our texture, which is going to be this, though I think I might be doubling it. We'll see what happens. And estimating where each pixel of that will go on the screen and do a scan line going across. Doom is a 2D game. It has no 3D setup. I mean, sure, there's a height map and all that, but there is no 3D in Doom whatsoever. Even if you have mods that can give look up and look down on mouse control, there is no 3D in Doom. You can be blocked by an entity at the bottom of a pit from crossing across lanes because all logic is done in a XY framework. Or technically an XZ framework. But anyways, I also have a magical mystical formula which came into my YouTube feed. I'm sure math people would understand this. Whoops. Where x prime is x prime is equal to x over z, and y prime is equal to y over z. And maybe I'll get to implementation of that at some point, because that sounds like it'll be good for billboarding sprites in the background. But that is neither here nor there, because I'm just doing ground first. So anyways, the basic idea given where we are standing, let me just make a quick little thing. I'll save this in there. I have to do some magical surface things in order to do what I want to do, but we'll get to that in a second. Actually, I could just do this, I think. The newest A sprite allows diagonal symmetries, which are a godsend. So anyways, this is the sprite at full for the ground that we're having. I'll change it later, but good enough for example. So in order to squish it, so very first off, with no perspective, whoops, we would squish it down, which we can already do with STL2 because we can take, it'll automatically calculate when you do this. However, the perspective stuff is where it gets a bit interesting. So, in a naive sense, we could also then, at each pixel level of the output display, take a corresponding chunk on this one, and each scan line going up, decrease it as we go along, all the way up to some sort of vanishing point, which I would probably say is a lot higher, so we don't have infinite distance at the end of a room. So probably something more like up here. So parallel line would be like right here, which is swallowable for like long distances, like even across a small room. So that is effectively the goal. So first off, let me minimize this. Our old friend. Our old friend doing some simple menu stuff, which still works. And I should have implemented more directly when I was trying to do Dragon Quest the other week, but I went down a rabbit hole. This has no rabbit holes, because I can't sit here and try to decipher bit shifting for RPG battle formulas from a game that's older than me. Anyways, let me just pop in there a sec, because I want to see what my resolution is. I think I have it as NES resolution, which should be my constant folder. There it is, 256 by 224. Sounds great. Let's do that. If I was doing this sanely, I would just be... I'm just going to do grass right now. That seems the proper thing to do. Oh yeah, this isn't exactly perfect. Well then, let's see what happens. I'm curious. Let's turn this one off though. So, I'm probably going to need to have a I don't think that's working the way I intended to. Abort. I'll just cheat. Let me get in a chunk of this. So what I'll need to do is have... Whoops. Wand tool, please. Now I lost my train of thought. Okay. So I'll need to have this, and I will need to blit it into a surface at twice its size, so that I can always have the top left be within here, but still copy over into like the other side and wrap around. Now I could do this through harder programming, but one, kind of complicated. Two, I don't want to. So I will do the classic trade-off for ease of use, or trade-off of memory for ease of use that every modern programmer does, but yeah. Though I think old SNES games probably did this too. 1 second, I don't think it shows, but I don't know where it's pointing to right now. So once I have this background done, I can then... Yeah, that was a little off. Fake 3D stuff. Art folder. Background texture. Save it as my ASprite file. And then export it as a ping. Okay. I'll check manually just to see if it got populated. Art, background.ping, sure. So, first things first, in my giant, terrible, ugly... Oh, I don't actually have it in here. That's surprising. Do I have it in my render? Or is it heartbeat controller? I don't know where I put everything anymore. Go away for a second. There it is. Background texture equals image load. I'm just going to copy like this. Now here's a question. Nope, the render should be fine. I want to blit this into a surface that is twice the size. Background texture called it. Copy it exactly. No need to typo that, which I will repeatedly. Okay, so we have this. Now I need to pull out some of the... Oh, that's why. Okay, one second. There we go. SDL surface, I think it is. Why are you acting up? Okay. Now I'm going to need to pull out some of the SR, or some of the, what do you want to call it? The files, or the file documentation, SDL2, surface. Because what I want to do, as I said before, is I want to put it in there so that I don't have to have multiple cuts of the same texture on the screen. So basically, I'm booting up the surface as a way to copy from later. This is how you can have like technically, you could have decals that are done this way. I don't know if they just have their own texture in memory, but anyways. What the heck is a pitch? Oh, okay, so you can actually access directly the pixel data, which is interesting. That's not what I want. SDL2, copy from surface to render. Nope, that's not what I want. So I know there's a way to copy from surface to something else. Render copy, I think that's what it is. Nope. Sorry, I'm doing a bit of hunting. This is what happens. And yeah, some of those mods get really, really out there. Okay. Isn't that? Let's hunt down the renderer chain and see if there's anything in there. So I think this is the main way. Okay, so we have surfaces. Is there any category surface? Let's see if there's anything under there. Fill Rex, Git, Clip Rect. Surface palette, that might be used for other things. Has color, fill Rex, free surface, no. Convert surface, convert pixels, no. SDL2 surface to texture. This might be the pathway thing. Yeah, create texture from surface. Okay. Because I've done this before, because one of my tricks in the past was to push all the background to a surface and then just blit that to the screen. Great texture. Render copy. Sorry, I'm getting a little lost in the weeds. You know what? Just for this, in order to not have me spend 3 hours trying to figure out how to get a surface, I'm just going to double the size of this and call it a day. Times 2. Times 2. Sometimes I hate how this works. Okay. Canvas scale. Times 2. Times 2. Put it up at the top left. And we'll do what I'm attempting to do without actually messing around with memory to get what I would think would be a simple option of like, hey, I want to put data to the surface. Nope, that's going to require hunting through documents for an hour. That isn't good watching. Okay, there we go. Room. Okay. So let's go back to our main over here. And we're going to need a render 3D. Or we'll call it render ground. Okay, where's the button to just make a new file as I can't right click. Render 3D ground. Header. And as always... Actually, nope. This is the one we want. Copy all the generic stuff. We don't need to have any of this because this is not going to be skewed at all. So void. There, okay. Render ground int or const int. I'm thinking. Yeah, we'll just call it player X or view X and const int view Y. We might not use Y because I'm not having any look up and down, but just in case in 10 minutes if it is mathematically good. Okay. I'm going to just put it here, const int, or no wait, const expr int horizon line equals screen height divided by 2. And this interpolates it at compilation time, so this doesn't have to be defined and I can pass it through things, but either way, silliness, it doesn't have to compile at compile time. It compiles at, or compile at runtime, it compiles at compile time. Fun see things. Okay, so first naive approach, we are going to get SDL rect. And this can remain pretty standard. Ground rect as screen height and screen width. Now this one will we'll get to that. Okay, first off, we have that. Now let's just get that rendering to the screen and call it a day. then we'll work on the next parts. So, STL, render, or copy. We don't need the EX, because that's just rotate and all that. Main render. Background, texture. And we can use ground rect for both because it's going to be copied same to same. Okay. Oh yeah, you put a ampersand in front of that in order to get its pointer location so it can be properly passed into that. There we go. And I will main loop on this other side because... or on the main, because why not? Not getting into here yet. This can be its own can of worms when I get there. STL setup, test menu. Well, actually, maybe I could just, you know, copy and paste this over. Oh, that's a space out. Weird. Okay. Test. Whoops. Room. Is that lining up? Nope. Okay, and... is there anything else in here I want to capture? Nope, we have the main heartbeat. No, that's not in this one. Is it? No, we do a basic pull event to die there. Okay, there's top heartbeat. Okay, we want to render clear, top heartbeat. Yep, okay, everything's good. And the top heartbeat is to control... pound include heartbeat controller.h. So basically all... the top heartbeat is a glorified hold that will happen, and then it'll do the update controller, so I don't have to re-implement this across a million different things. And that's the story, and I'm sticking to it. Okay, render ground. There we go. Ground is rendered. We go back into here. At the top, we include our render 3D ground, and then we're able to replace all this with whatever I called this, which was test render 3D. Okay, I hit the button. I hit that button. I get terrible errors because I forgot to hit a semicolon. Oh, my bad. 00 should be fine. Everything's good. Okay, now that I have this, let's see if that pops up on here. So I'm going to hit the button and it should just copy to the screen. And it does not. Frustrating. Okay. Let me just do a little bit of debug. So I'm going to put some... I forgot to hit the STL. What is it? I'll take a look over here. I forgot to have this little sucker at the bottom. There we go. So what's missing from this is that it never actually renders to the screen. Everything gets set up to be rendered, but the actual blit to our window does not happen. That's wrong. What's wrong about it? Do I have these backwards? This should be XY. XY. Am I correct? X. Oh, no, wait. No, no. Is it backwards? This is the one thing I always kind of hate. Yep, it is backwards. Okay, there we go. We got this. So, now, STL rect screen projection equals 0, 0, or no. 0 screen height divide by 2 and 0 screen height divide by 2. So this is our first basic idea, where we will just squish it. And that will get us our basic that should be right. I am doing these right, aren't I? SDL rect. It's XY with height. Oh, wait. No. That should be correct. Okay, let's just put it at 0, 0 and see if we could do half this. Because it should just squish it at the top of the screen. But it's not. What's going on here? Because literally if we just... Oh, that's why. That's why. It was a width of 0. My bad. Okay, that's fine. Okay, just to prove it. 10 pixels by 10 pixels. Can we get something to the top left corner of the screen? Or am I doing something wrong? Okay, we can. As you can see, this is shrunk down. So if we stretch it to screen height, it'll stretch vertically to take up the entire thing. What's going on? So I know you could squish them this way. But it won't do it at 10. Is there some sort of weird... Okay. Working as expected. Did I just not hit save right? Possibly. But you gotta test. Okay, so half screen. Screen height divide by 2. This will put it in the middle of the screen. Okay. Or as we really wanted to have it, horizon line. Okay, so we got that. And now screen width. Now, this isn't very 3D yet. We got this. We got our little thing squished. Technically, we could round it out more, but I'm not going to go that far. I just want these to go diagonal to a degree. So, I am going to do my next part. which is STL rect ground line, which is equal to that screen width and a height of 1. And this is going to be somewhat inefficient, but it's going to be a proof of concept for int. Yeah, we'll do y. Y less than screen height. Y plus plus. We'll go through and update ground line, its y coordinate to equal y. And we will, I guess we'll also need to have a projection line. Well, it wouldn't be at horizon line. It'll be updating as well. So this one's just going to do, I want the edges to come in to about halfway, to half a screen at the top. That's the goal. And since that's like every other 2, I think I can just... Now let's be inefficient for a minute. Let's actually get down our ideas before we start pre-optimizing that. And we'll set up an int here. Int screen x equals 0. Because that'll be the left-hand side. Screen x equals y divided by 4. No, I just want it by 2. Okay, that would make it so that at the very top it is... Yeah, I want to divide by 4. That'll make projection line dot x equals screen x. Projection line dot width equals screen width minus screen x divided by 2. And this is going to squish it so it's basically like a triangle going up. Oh. Okay, and then we get to the actual render, which is STL render copy, main render, background texture. At ground line at projection line. And I think that should do it. It might be horribly inefficient, but we'll see in a second. And nothing's rendering. No, wait. It's all rendering as a tiny pixel at the top of the screen. I screwed up the Y. Okay. Screen. Or no, yeah, I need to update the Y so it actually goes right. Dot Y equals screen height over horizon line times Y. And I think that should do it. We're getting somewhere. This is skipping every other line, and it's kind of interesting. But it's not what we want. I should make note of this, though, because this might be useful for something. Okay. Me being smart not working. So, screen height minus y divided by 2. So it's going to slowly go from the bottom up. Because 0, 0 is at the top left of the screen. Okay. This is actually working. This is what I would expect it to be. It's hitting the middle of the screen and everything is curving in. Well, we are not getting the very left-hand side of stuff because this is the edge of the texture. We need to do more for that. So... oh, Sonic 3D Blast. So the next part is ground left. Or no. This is ground left. Divide by 2. And ground right. Actually, do I need to go that far? No, I don't think I need to go that far. Yeah, I don't. What I need to do is figure out that there's something a little bit odd with the screen. Because the width should be shrinking, but it's not shrinking. So screen height minus screen x, which is y divided by 4. Let's just say minus y. Let's see if that helps us any, because that should be shrinking just as fast as going up. We're getting there. It's more of a y divided by 2 then. Whoops, that's not what I wanted. Okay, there we go. Now, the other problem would be for filling in these. Because this is just this entire texture. This entire texture, well, the top left quadrant of it, spread over this. So, honestly, because we do have this texture so big, we could just kind of live like at the middle and just fan out. Like, we could render the entire texture onto here and not have any ill effects, but I wanted to have it so that if character moves left or right, it kind of skews what's going on. So, like, if you're in the middle, this lines up correctly, but if you're over here, this now becomes kind of the straight one. I also might want to have it be progressive in that it... I'll be honest, I think Harrier was the one I was thinking of for how to get this effect. Let me just take a quick look at one of them, maybe even get a screenshot. Sega Harrier, I think it was called. Yeah, this is good enough. So you see the effect I'm kind of going for. I even went with the green. But you can imagine it being dungeon tiles and all that, and I could use it to make a dungeon crawler. I mean, honestly, they probably aren't using textures and are just filling lines. But same principle in the end of the day. They're doing it a lot skewier than me. But they are putting it to the middle of the screen. Actually, are they doing more skewing? Yeah, a lot more. Actually, I could even go in there and count the pixels. Ooh. Ooh. Jaggies. My hated... Oh, look at that. And it progressively gets more as it goes along, so... Maybe there's a formula I could think of. I'm sure somebody who knows how to do math. Yeah, yeah. To use maze walls, you just drop them down normally. Only the ground is skewed, and then you just billboard and like increase and shrink the walls in the distance and just render them backwards if you render everything. But if you are able to occult some things, you should be able to do that. And then you have your billboard sprites that are scaled as well. But anyways, let's get back to this. So, oh, I still have it up. Okay. I mean, technically, if I was doing dungeon, it'd be like the third or whatever, but, I'm trying to think if there's a way I would be able to get what I need. Anyways. So, since we effectively have twice the area to work with, we can work at twice the size. We'll be rendering stuff we don't need. Well, the thing is not to have leaning walls of things that look jank. That's the truth of design, is to avoid the things that look bad. Okay, I think I know what to do now. And the answer is be very dumb. It's the best answer. And this will be... Well, if you want it big, you just have it go off the... Or tall, you just have it go off the screen. And projection line is... Wait. Divided by 2. Minus that. Plus that. And if my math is correct... Oh, just look at Doom. Okay. Now, the width side... Whoop, nope. Plus screen width divided by 2. We're getting there. Oh, okay. I'm going to... Okay. So the middle is basically right here. We need to kind of shift this over. screen width divide by 2, or minus plus the... Oh, that's not the right area. I don't know why I keep doing this. This is not quite doing it. This is like moving it too far. If divide by 4 kind of make... I cannot hit any keys. Well, the hands are broken, so it doesn't matter. So that's kind of expected. Okay, there we go. It's divide by 4 for no apparent reason. And we get the effect. Not the most convincing. Let's go at a higher raise. So that is 8. And that shifts us over again. This is kind of silly. Oh, maybe it should only be 8. Nope, still too far over to the left. Six. Four. Nope, that's pushed us too far over. Okay. So let's just keep working off this until we can make something. That's fine. There's a bit of weirdness going on back and forth, but I think that might just be rounding errors and something we'll have to deal with. But the basics here is kind of working, which is more than I could say for what I expected to do in about an hour of time. Oh, okay. I think this is where I want to put the 4. And I think this gets a little... That skews it. There's math. Now I could pull out the big boy and just do this pixel by pixel, but I think that would be too much for me. Maybe. Because the whole formula as I had before, x prime equals x over z, y prime equals y over z. Z being retreating into the distance, which I could easily emulate. I mean, effectively y is equal to z. And effectively, all we are doing is getting points. Do. You know what? Let's give this a try. I'm going to keep this for a minute because I'm terrified of losing this basic working model. And I'm going to use this math. So, let me skeleton out this code. Texture line is at point negative. Screen width divided by 2 to positive screen width divided by 2. Projection, or Z equals Y equals texture Y. So effectively this would be Z. We'll call this Z. Okay. So projection line is still good. Don't need to do anything here. Just need to make that Z. And projection line.x is equal to screen width divided by 2 negative over Z. And we want to int this because int so we truncate any digit, all that. And projection line dot width is equal to int. Now the example I was given with this stuff used it all in 0, 0 is middle of the screen, and everything, and like 1 is the right hand side, negative 1 is the left. I don't know if I need to go that far. I might. I'll find out in a minute. No, actually, what am I doing? Okay, y is equal to, well, I guess it would be z. Screen height minus z. Okay, let's just go with this and see what it does. It's going to be wrong because it's not going to do the left side. It's going to just be shifting everything over, but that's fine for figuring this out. Why are you yelling? No, you're not. You're literally right there. Okay. You're fine? You're fine. Oh, is it divided by 0? Probably. Okay, well, equal to 1. Get rid of the divide by 0 business. Whoo! That's interesting. Projection line dot. I can't copy anything. I can't spell anything today. Okay, width equals to screen height times 2 over z. Welcome back. We got math exploding. I don't even know how to explain the fact that it's doing a... Oh, what kind of curve is this? Okay. Let's revert back to this just being a single screen and we can see the edges. Well, that's always going to be 0. That doesn't make any sense. Okay, maybe this does have to be projected into... Ugh. I find this dumb that I have to project it through the system. Okay. Okay, so we have to make it so that 0 equals -1. Screen width divide by 2 equals 0. And screen width equals 1. Same for height. 0 equals 1. Screen height divided by 2 equals 0. Screen height equals 1. Okay. So effectively, everything is going to be done in screen width divided by 2 plus screen width divided by 2. This is dumb. Okay. Or minus screen width divided by 2. It's going to be done in units of screen width, then -1. Is that what I'm thinking? So we have 0.0. So 0 times S2, we'll call it, then -1 equals -1. If we have screen 2, or negative screen 2, no, this would be divide by screen 2, we get -1, then -1, which gets us -2. And that should be correct. Okay. I'm going to make some constants because this is going to get confusing. Why can I not type today? F screen height equals screen height divided by 2. All right. So none of this is going to affect the projection line coming in. So projection line, or I mean the ground line. ground line dot y equals z. That's all that's going to be happening. Is it's going to be ripping from the top to the bottom, or from top to top. So that's no change. We need to do math here. So int point x is equal to -2. That's where the left-hand side is. Int point x max is equal to +2. Also, z has to be put into the current system of... okay. Divide by... yeah, okay. Divide by z, which is divided by screen height. I am not made for math. I am made to just push things into working systems. Okay, so we get that. And to deconvert it, min is equal to times equals screen half. Screen, what the heck did I call it? Half screen, okay. Half screen w point x max times equals half screen w. Int point y, because we don't need the min or max because we aren't doing anything on that, is equal to int z, because z is also y, over half screen height over... no, that should be... yeah, that should also be half screen height. I think this needs to be simplified in a second, because that's always going to be 1. Oh, no, wait, because this gets -1. Okay. Because we figured that out before, that we have to -1 from this in order to get where it's supposed to be. So would this mean that this is -3? 1? No, that can't be right. Maybe. Okay, let's just see how it goes. So what this means is that point y times equals half screen height. Can I not spell? What is... oh, I didn't put that over here. Okay. We have that. We have projection line dot x is equal to point x min. Projection line dot width is equal to point x max minus point x min. And projection line dot y is equal to point y. We put the semicolon there. And we see how badly we screwed up. I'm expecting a crash. A blue screen if we're lucky. Okay, so there is a 0 factoring its way in here, probably. Yeah, because that's getting turned to... If I chop that out, which I don't think will actually work... Oh, this is dumb, because I have to deal with zeros, because, like, that's behind you, or whatever. Yeah, that's not doing anything now. Actually, let's use some debug. You happy? Oh no, STD. There we go. Okay, most of these are just coming out to 0, 0. And then occasionally we get something that's -3, blah, blah, blah. So, formula is not working and putting everything in the wrong spot. I really hate working in this system. It's like, it's simple, guys. You just need to have all the coordinates put in the right coordinate system you're working with when you're... Yeah, totally. This is what I want. Honestly, I was having a better luck over here, except it's starting to get weird skews and all that. God, I hate working with this sort of stuff. Because, yeah, I had watched a video where basically all the model stuff they had, just the points, it was already in the -1, +1 coordinate system, so they didn't have to worry about that. But I do, so I have to translate like 3 times, and I'm screwing something up, so it's all just ending up at 0. Which means don't render anything. I'm breaking this out for a second. So effectively, what I'm saying is that we have the screen. This is -1 over here. This is +1. This is -1. This is +1. But, you know, this also equals 0, 0, and this equals 240, or 240. And, you know, proper coordinate space that actually makes sense to anyone who does anything. So we're like working in a unit of half squares. Or of the halves, which is the whole reason why we have the half width going on. And then we have to translate back, which is just times it. So our main projection, because we have effectively at -2 the edges of our texture, and at +2 we have the other edge of our texture. Where we're having some issues. I mean, I guess we don't have to go out that far and can just say it's -1 over z. But z needs to be normalized into the components, so like this is going from 0. Let's use this. to 1, I guess. I guess negative 1 would be behind us. And so this would also be as pixel length half screen. Yeah, so I do think, okay, if we start at that, point Z is equal to int. Well, we can't do it in ints then. Yeah, we can't do it in ints. We're losing all the precision. That's probably where everything's going to crap on this. Yeah, what am I thinking? Ints are truncating everything off. We don't get anything out of that. Make it a float, call it a day. Yeah. No wonder why everything's at 0, because they can't get past 1. And then we have to int down here. And what was this? This was negative 2, 2. Yeah, that's fine. Do I think the Z is going to screw everything up? Yeah, I'm pretty sure the Z... Because the Z is still in its weird space, we're going to have to make a float. Point Z is equal to Z divided by half height. Because we're half screen height. And instead of using proper Z, we want to use point Z. And we don't have to convert that back. You'll be fine. Okay, I think we're good. Let's see how badly it crashes. Nope, okay. Point X min. Oh, thank you for not taking that. Point Y. And a slash n over there. We'll call it a day. There you go. Oh, we're getting affinities. Negative 256 to infinity to negative 256. Like, what the heck? Okay. That's interesting. Okay, we're getting something. It's one line. But it's not projecting as it's going up. Probably because the Z is linked to that. What happens if I put this as -1? So it's on the ground. Will that fix everything? Nope. If I put it at 0.5. Well, it's on the top head of the screen. It's where I would expect it to be. But it's still not extending out. Hmm. Hmm. Because I would still think that it should be on Z. Because otherwise we won't be able to extend out. Because effectively the... Let's bring this back up. So I keep saying it as Z because... Well, how else am I going to put the square on? The square doesn't exist anywhere else but on the Z-axis. And we're just taking we're taking like single pixel slices and reblitting them. All I want the system to do is just constrict this to a vanishing point. And it's almost working, but it's an infinitesimal slice. Say this. Which, I mean, I guess would be correct at the very bleeding edge. Z over screen height. I think that's what we need. No? Okay, well, it's up at the top of the screen. It's going off into infinity. So... negative. Let's put it at the bottom of the screen and have it go up. No? Times 0.5. Something at the top. We're getting real interesting answers of infinity and not a number. This isn't getting me any closer to it. I think I'm probably misunderstanding what point Z is in this, but I would assume it's the slice of how far the object is away from you going through this, but I might be completely wrong on that. That might be something to revisit. Oh well. I'm going to reconvert this back to the other one because I'm not getting anywhere with this. So you become Y again. You go into the void. Group. It's getting somewhere, but I'm misunderstanding something from when I read the notes I wrote down, and it isn't getting me anywhere. So back to this, because this is working, and working improperly is better than not working correctly. I deal with not working correctly every day at work. So we have this. Could it be better? I mean, this technically works. You would swallow this if this... Well, let's have it actually... go the full distance. We have this go Y. What happens? Like we got a perspective there. It's mostly like looking down at the ground. If we divide by that 4. That's not too bad. Out of curiosity. What's weird about this? Wow, that's actually interesting. Because it's becoming more square as it goes towards the top. That's backwards? I mean, if this was curving, that would make sense. That's real weird. And this is just a linear function. Yeah. Strange. Second, over here. Oops, wrong button. I'm just doing something quickly. If main controller dot left greater than 0, or x minus minus, else if main controller, same thing, every 16 frames we pull for the first one, x plus plus. Just some silliness. So we're going to have a little bit of move back and forth. Actually, let's pull every 4 frames. It'll make it look faster at the very least. Now the issue is that like we would have to have a texture be a lot bigger. Because right now it only goes off like half a screen. So you already get the edge when you start like moving over. Like if we put this at the middle point, we've lost half of it. At more than half at basically half the screen. So I'd have to have like a texture that's a lot bigger, which is why I wanted to do it all in memory, where I just make a really big repeating texture and I'm able to just blitz to the screen, because otherwise I have to do subdivides and that's a lot more blitz to the screen. And that's not fun. Why does it change curve? Because this is, no, the curve remains the same, but it starts getting bigger up there. Weird. It's not consistent. Why is it not consistent? Actually, that was at 0. So view 0, like... Yeah, I don't know. I don't have the math mind to figure out why it's warping and effectively, like... It's squishing down, but the Y's aren't squishing down, but I assume... But that kind of actually makes sense, because I'm only compressing it on the X-axis. Though technically the Y should be also changing. But that, once again, would require proper math. Maybe later. I think I basically got out everything I wanted to do. Well, I guess there's one more thing. I could try and billboard something, make a billboard sprite that scales where it is on the Y. Sure. 256, 256. Let's make these chunky thing. This is a chunky thing. Okay. Billboard sprites. Okay, and as per usual, we have to get that texture in there. So in the render engine, where are you? That's player. That's not render. Enemy render. Yeah. Nope. I can never find anything. There it is. So when I say billboard texture, this is effectively what Doom does. It takes a known texture size and just changes it depending on how far away, which is effectively going to be Y on here, but either way. Let me just copy it exactly, because there it is, okay. N is a ping. Yeah, I spelled it wrong. Okay, whatever. Oh, and it put it... Yeah, I put that. Are we good? We're happy. Okay. Now, over here, I'm just going to have a singular enemy. Which is going to be 16 by 24. I guess it'd be Z. This is how far away from you it is. Let's put this down here. Yeah, there we go. Okay. And why did you automatically complete there? What did you add? Nothing. You just added an extra right bracket. Nice. Okay. So int project size equals Where project? Or project X equals, what is it, 32 times Z over screen height. We int that. Because I'm using the height as the Z for the most part. So if you are screen height away, you're basically 0. If you're right in our face, it is perfectly aligned. If Z is greater or equal to screen height, return. No need to render because you're off screen. You're out of you're at a distance greater than we care about. We do need a Y because we actually need the Y point around the screen. Anyways, Z is just how far. Project Y is the same thing, except we are using 32 plus 16, so 48 times Z over screen height. And then the X and Y are still going to be the X and Y. Do we want them to be the middle? Sure. So anyways, STL rect. Let's make one out here. STL rect enemy sprite equals 0, 0, 32, 48. Right, sheet, and we make another one for the sprite projection. Alright, so enemy sprite sheet we already have. Dot x equals sprite x, enemy sprite sheet dot y equals sprite y. Enemy sprite projection project dot x equals x, enemy sprite project dot y equals y, enemy sprite yeah, it doesn't matter. Project dot width equals project x sprite. I could go for some sprite. Dot y or height equals project height, and then we do the good old fashioned. Oh, that's up here. Can I just copy the whole line? Nope. Of course not. Why make? I can copy the entire document or the text before the line I want to copy, but just double clicking to copy the line, that's too much. I don't know. I'm just really kind of tired of everything being weird and not actually working. But it simplifies things. Okay, so we have that. So we're going to take the render out of that loop and put it down here. And we're just going to have int enemy x, int enemy y, int enemy z equals screen height. And all we're going to do on changing that is just using if main. Really? Okay. Control dot up mod 4 equals 1. Okay, so we got that. Grab you. You probably should be like screen. The Y will put it at the bottom of the screen. So I might have to change that at some other point, but right now let's just get stuff working. Don't need that. Need to replace with that. Okay, let's see how badly this breaks. Okay, let's put this at like 5x2. Let's even remove ground for a second. See if things are actually properly blitting. X, Y. So it's blitting at 256. Okay, that's probably why. That's probably why. That's not the right texture. There we go. Probably also blended in. Oh, thank you. What did I... Oh, you ate the comma. Very useful. Ran into that before, where it just like eats syntax in there. Okay. That's working as about expected. I'm actually surprised that's working correctly. Because Y would put it... No, okay, blitz down. Yeah, that's fine. Trying to think, because if Y was at the bottom and it was pushed out more, it'd be proportional to where it should be. And what am I using? I'm using the horizon line, so if all the way back horizon line is half screen, so Y Y at screen height would be 2 if at same spot at Z equals 0, it would be full screen. So what does that give me? That gives me 0 equals screen height. 0 equals screen height. Screen height equals screen height divided by 2. That's clearly a linear correlation. So what can we do with that? I'm braining hard. Okay. I think the other way would make it easier, but I don't get to have that going on here. So screen height Y times Z. And how is Z proportionate? So Z is equal to 0, Z is equal to full thing. Minus screen half screen height plus Z over screen height times half screen height. So when this is at 0, it's only half screen height. When it is at 100, it is full screen height. The only problem is that when this is at 0, it will raise it up half screen, which is not what we want. Times over screen. Oh, this is so dumb. Oh, I closed my thing that I used to open. Okay. Command window, pop back open. Bring me back to my program. Okay, so it's still staying at the top there. Let's put, whoops, him at the bottom. So Y equals screen height. So this should put him at the middle of the screen. It's putting the top of it at the middle of the screen because that's where it's splitting from. It's not moving the Y position. As it gets smaller, it should be fading up. As it gets bigger, it should be fading down. Okay. So we have Y. Y is at the bottom of the screen, or should be at the bottom of the screen when it is Z's at its highest, or am I getting stuff backwards? So pressing up decreases the Z. Yep, it goes back. Pushing down increases the Z. Y is equal to... I think maybe some math weirdness is going on. We'll see. Nope, nothing changed. Float offset equals... So this is a scale between 0... Let's just do this as a pure scale. So Z over screen height. Because if we reduce this, it should be fine. Because if it's at the top of the screen, it always stays at the top of the screen. Which is 0. Okay. So as it goes further away, it stays there. As it gets closer, it should come down more. But it's already at halfway. So it should have been at the half point already. That's more of a scale than offset. STDs, C out, scale, Y. And then we get the enemy Y, and then new line. I used to say Endel, but wait, did this not compile? So I'm having blidding at. I should be seeing scale. Something else doing blit at? No? I must not compiled. Clear screen. There we go. Yeah, scale's just being 0. So scale is always being 0. That's not good. And let me just see what Z is coming in, because if Z is 0, that makes sense. But I don't think so. Nope, Z's coming in as that. So it's like the scaling is getting screwed up. If I make it a double, does it make everything better? Because I shouldn't even be bothering. Because it's... No, I'm still getting 0. If I do it raw in here... Oh, thank you. That was very useful. Oh, wait, that's a truncate. I put the wrong one in, didn't I? No? Am I just... No, no, no. C can't be this stupid where it literally you can't try to get or it's impossible to get fractions from anything. That'd be utterly stupid. What am I... Do I just not know how to divide anymore? Is there a float dev I need to do? What the heck? This is not a... Z is that. What? C++. Divide. Or is there a float divide that I should be using? No, it uses that one. What the heck is going on here? Because I'm getting 0 back from 112 being over... and that's not how it should be. I might call it quits in a minute because I should probably get to other things. And if I'm going to be debugging how to do basic division in a computer language, I'm not doing that on stream. Yes, thank you. I needed that entire screen full of something to see. I want to see 2 divided by 4. Because if division is being broken, like if there's a flag I need to set... No, like 2 over 4 is too much for this to handle. No, that's working. So is it like implicitly converting it to an int? Because this is coming in as an int? Do I need to convert this to a float first before it... Because I thought C was the king of doing terrible things with floating values. Okay, there we go. It was that. It's because if you have ints and ints, they it just makes it be an int. Okay. This works better than expected. I mean, it's a linear thing, but... I just need to figure out a little bit more about that math stuff so that I can do the proper scaling of the ground floor going up, and then I can have the billboard sprites be out there in the distance. and then, you know, come up. Okay, that was sort of dumb. That was... How should I put it? I'm used to C plus just doing whatever it wants unless you explicitly say things. So the fact I needed to make these floats beforehand and completely change how it does that is surprising, and is probably giving me math problems and other things. So that's nice to know that I should probably convert them to floats beforehand to get actual proper division. I didn't know it was that strict and would actually just give you ints and like not do anything. Good to know, I guess. Because I had to do that in Python, and I guess it carries over from C++ and C family. Because in Python, if you have two ints and you do any division, it will do integer division, which will mean you don't get fractions, and you generally have to like put a plus. You have to convert one to a float or add 0.00, which is 0.0, which is the funniest thing to get it to work. So, okay. I have effectively done everything I wanted to do. The only thing I guess would be like hit scans and other such things. But that seems like a lot of work, and I just wanted to do a quick sort of win. Actually, let's put the background back on here. How does this look? Let me move this over. Yeah, I need to figure out how to squish the top ones progressively more as it goes along. So I might need to look a bit more into that, and then I'll get this working. But otherwise, I guess this is a win. I mean, if I cut out, like, right about here, like I had things come up off that, that's pretty much what I want. I might have to fiddle a bit so like they're really small back there, and then they get bigger. But that's what I wanted to do. Okay. That said, I'm going to call this a day. A rather quick stream, but that's all I wanted on this one. Simple little sprite system to do pre-Doom things, and I should probably look into how the formula I wanted is not working. There's something mysterious about that X over Z and Y over Z that I'm not understanding, or at least I need to convert more into a point space where your eye level is 0, 0, 0. Either way, that's it for today. Next week, probably art. We'll see. Either way, until then, I will see you next time. I don't know. Hit me up on the Twitter at Scribble in the Moonlight for commissions and stuff, but I don't know what else to say. I'm signing out. Have a good time of day.